Welcome, everybody, to our next Megabrain, number 10. Thank you for being here. I'm seeing a lot of names that are really always here at the Megabrains and visiting us, and some new names as well. I'm so happy to have you here. We have, like always, 3 very interesting sessions in this Megabrain with professionals from our industry, and are covering interesting themes for very different parts of our industry background. So the first session is going to be with Alex Richter, and then we are he's TD. I know him also personally, has his TD Academy, and he is going to talk a little bit about Python and visual effects. I think this is the theme that everybody's interested in, no matter if you are a beginner or advanced. You can always learn something. How do people approach on solving problems with Python in different areas of visual effects? Alex, the stage is yours. You can take over and start your presentation.
Thank you, Argon. Can you see my screen? Can you see my mini me pointing at the slides? Awesome. Thank you very much. Thank you for the invitation. It's a great pleasure and honor to be here with you guys. And so basically the topic of today for me is Python for visual effects, animation and games. And my name is Alexander Richter. And the main idea today was to talk about the topic of Python specifically for our industry. I also, since I was not 100% aware what kind of spectrum we have, I tried to make a big bridge between beginner people who never touch Python to people who are already using Python, and try to kind of collect everyone in this and talk a little bit of the impact and the way Python is in our industry and where it should be. And the main point that I like to make when it comes to the whole presentation, and that the takeaway that you should take, is that the artist of the 21st century needs a scripting as part of their skill set. So if you think about what an artist generally has to do to be successful in the industry, visual effects, animation, and games, is obviously to have the skill, then branding, because we need to promote ourselves, we need to get hired, like freelancers especially, and so on. Obviously teamwork, we rarely work just solo, only and when we learn, basically. But then we have the scripting aspect that becomes more and more important. And the simple reason for that is because the amount of work that each artist has to handle becomes bigger and bigger. If you look at the shots that are currently processed for each project, and at the same time how many artists work on this project, it's kind of small compared to 10, 20 years ago. So basically my statement is art needs artists and a production needs automation, which leads us to you need scripting skills. Before we dive into that, let me quickly introduce myself so you get a little bit of understanding who I am and why I'm saying this strange things maybe. So my name is Alexander Richter. I'm a technical director and coach for visual effects, animation, and games. And I worked on Avatar: The Way of Water, Shang-Chi and the Ten Rings, and Monsters at Work at Weta Effect, Framestore, and few other companies. And especially for this talk, I think one of the things would be very important is to get a little bit understanding of my scripting background. So basically, I have a bachelor degree in media computer science. I have a diploma as a technical director. Yes, actually exists at the Film Academy. And I work as a pipeline lead professionally at Studio Zoe, Arx Anima, Warp Animation Studio, and Weta FX. And I created the open source pipeline Plex, which was created for the short film Breaking Point, which the team and I won the VES award for that project. And this is how it looked like at the end of the day. It was basically a pipeline tool to navigate through Houdini, through Maya, through Nuke, and help the artist, to save, export, publish, import, and so on. A typical pipeline elements, and that help the team to make faster decisions, iterate faster, and basically create the project that was able to win the award. And then also I'm doing Python lecture. So I was doing lecture at Artifacts, CG Master Academy, Effects America, and I also have my own website where I teach Python for Maya, Nuke, Houdini, and Next and Advanced. So I'm not just randomly saying things about, hey, everyone should learn scripting. I actually believe that it is important. And if you look at nowadays world and the things that we use, it's very technical. Every tool that we use is not just Paint anymore. Maya, Max, Houdini, Nuke, everything is relatively technical. At the same time, there is this huge amount of production. So my suggestion is that everyone should learn scripting to some degree. The big question is, what would be the best way to approach this? And there is a simple answer, as you know from the title of this event, of this talk, basically, is to learn Python. Because Python is the scripting language in visual effects, in animation, and partially also in games, because you can find it in Maya, in Max, in Houdini, in Cinema 4D, in Blender, in Katana, in Nuke, in all Foundry. Basically, every software that we generally use can be connected with Python, can be automated with Python. So it's kind of like a language to bind them all. So if we want to actively be faster in our work, even if we're just artists, we're not programmer, way to do that is learning Python, basically. And not only is it important for us, it's actually became one of the most popular programming languages, actually a scripting language, in 2023. So Python is not only used in visual effects, research is using a lot of Python, and so on. So Python opens doors, not just for us as artists, not just for us as technicians, also doors in other industries and other environments. And the way that I summarize learning automation, scripting, and at the end of the day for us, Python, is twofold. So basically, we created two things. One, Python allows us to make things faster, and two, it makes things possible. So what do we mean if we say makes things faster? So things like save, load, import, export, which is like publisher, combining steps together, restructuring steps, and so on. So if you would think of what a normal production has, we typically have this typical save script. We have the load scripts, we have the publishing scripts. All these are basically summarizing steps. We can do it ourselves. We can go to menu, save, and then type in the name and so on. But on one side, we have to do all the steps, and they can take time, minutes, hours. And at the same time, we can make mistakes. We can namely wrong, position something in the wrong folder, and so on. So it makes things faster because we can just click a button. 5 seconds later, it's exported instead of 1 minute of doing things. The other side is Python can make things possible. For example, we can create custom tools that don't exist, or the tool that the software doesn't allow us to do, basically. We can create render threads, a certain eye light or rim light that is automatically there. We don't have to do it manually. We can create custom nodes, custom shaders, custom lights that are unique, that don't exist at all. Which, for example, if we think about it, a node network with customization is basically scripting. A node network is basically visual scripting. We can create student shaders. If you watch the latest Inside Out and so on, there's a custom shader into that. We can create new simulation, maybe a 2D fire, a fire that is not realistic, but is artistic, basically. We can work with procedural modeling, shading, textures, layout, lighting, all the stuff that helps us, to filter theme, make an environment. If we have hundreds of trees, a whole city, all of these, it's very helpful to do that. And last but not least, we can work with the more and more coming machine learning implementation, which I will talk about. I have a few examples in here for animation optimization and render enhancement. And if it's, for example, a very simple example is this tool in Maya. Let's say you are in the lighting department and you would like to have a custom light linker. Obviously, there are already light editor. But maybe for this specific person, for this specific project, there should be certain elements, certain light linking situations, auto linking, and so on. So we can create something that maybe doesn't exist, or at least helps the person, the artist, to do their work faster. So they can produce faster, they can tackle more shots, or make better quality because they don't have to rush as much at the end of the day. This is another example that I created is the IR write. It's basically a custom write node in Nuke, which creates this overlay with, information for reviews and so on. And some of it is you can do it manually. You can create your own gizmo, by building your own node. But some of it is also custom code that you cannot create just by building nodes. Some of them is calculation. Some of them is connection. For example, I implemented a render threads into that. So if you click submit, it will spread it out, which didn't exist at that time. So it means basically it will render the whole sequence on different threads. So it can basically use the CPU in this case more efficiently. And I did it by using Python to implement someone else's tool into this tool. So it's something that didn't exist in a combination that is basically new. So at the end of the day, Python is the glue between different software packages. It is the unifying scripting language that is used everywhere, even in video games where, at least in the asset department, Python is there. But even in software like Unreal, you can use Python. And this is basically a very important thing. And it's a way to speed up your workflow, and it's a way to create alternative workflows. Maybe something doesn't work. You can maybe bridge the gap with Python. It's also a great way to step into programming itself, since it's relatively easy to learn. And it is something that everyone can use because it's so widely accepted and used. You can be an artist and use Python. You can be a technical artist, use Python. You can be a technical director, use Python. And you can be a researcher or software developer in visual effects animation games and use Python, basically. And it can be a key language for machine learning. I will mention that again later. So for example, I created this tool as part of the Plex. So this is the IR load. It's a typical open and a load assets and shots, basically nothing fancy. But what's really cool about it, it's made in Python, and it's the same code in Houdini, in Maya, in Max, and in Nuke, and it could be in Blender, in Katana, wherever you want. Wherever Python is accepted, which is most of it, I can literally take this tool, put it there, add a few lines of extra code for Katana or Blender or whatever, and it will be the same script working everywhere. So you can see literally this is exactly the same. You can see the formatting and changes a little bit because the interpretation of how the UI is a little bit different, but it's the same thing. And I don't have to do anything besides that. I just created it, adjusted a little bit for each software, but this code is untouched for each of these things. And if we look about generally working with each of the software, like code-wise, maybe you're a beginner or maybe you're only familiar with one software. If we look about that code, it's actually pretty much the same. So for example, if you want to create a node in Maya, we just say CMDS, the command lines in Maya, dot create node, and then we'll say the node that we want to create, AI standing surface. Okay, what about Houdini? In Houdini, you would say OVJ because we have a certain node that we created, dot create node. And then create a GeoNode, for example. Okay, what about Nuke? Nuke.create node. And then we create a read. So you can see, besides, obviously, sometimes there is certain different in naming and the way that things are structured or something like that. The main purpose of how it works is the same language, obviously, but also often the same principles. Literally, all these 3 different DCCs use the same command, same function to create a node, which is create node. And that's really the unifying thing. Let's go to another example. I mentioned that Python is a good gateway into other scripting and programming language. Let's compare Python with C++, for example. If we see Python here, number equals 5. Okay. In C++, we have basically the same. The 2 differences, we need to define that it's a number type integer, and we need a semicolon. Okay, not much a bigger difference. If we go C++, gaming engines, very important. C#, Unity, for example. integer, number, exactly like C++, not much different. Mel, if you are working with Maya, especially at rigging a lot of them, same as C++, just with the $sign for this is a variable. And last one, JavaScript, which often is used for web, for example, var number equals var. It's basically the same. So even if Python is your first language, it would be easy for you to transition because the rules, let's say, are 80, 90% the same. And we have, for example, another example with VEX. Since I recently worked on Python for Houdini Masterclass, I wanted to compare how it is to transition from Python to maybe you need some VEX code because you want some optimization in your simulations. So if you see that, we define some students and we loop and print them out. And if we compare the top VEX code with the lower Python code, it basically looks exactly the same besides color highlighting that's missing here. It's basically the same. So when we learn something like Python, not only have a unified way, it's simpler than most languages, and we can use the same knowledge 80 to 90% to transition into Mel, into Blink, into C++, into C#, and so on. So it's a really a gateway into scripting in general. So that's one of the reasons, besides being the DCC, that why I'm so kind of focused. Finally, how I would like to end this talk is how do we learn Python? And I don't mean it as only as beginner. I also mean it as maybe someone who already started, but maybe wants to continue, grow into a higher role, bigger role, pipeline TD, and so on. So very important to understand when it comes to Python, Python is a language. And like every language, what we need to learn is vocabulary and grammar. That's an essential thing. But then with that, it's not done. What we also need to do is practice, do things with it. So the best way to learn Python after all the basics is done is to create applications. And when you learn Python, you should not open the book and learn from the beginning to end. That's just waste of time. Python that is needed for us artists, even as a TD, even as a pipeline TD, I would probably never need more than half of what Python actually can do. So we only should learn what Python really is necessary. You don't need data science stuff like that. We don't need calculation Python. Most of the time, it's not necessary for us. So there is a way to learn Python very smartly that allows us to learn it relatively fast. And so this is the graph that I created because I was trying to differentiate between beginner Python and advanced Python. And so basically, if you are an artist, you can have Python, but you don't need to do it. But the moment you move more into a technical role, and the moment you move more into a scripting support role, the more you become a technical artist, then a technical director. At the end of these, it's like the pipeline TD, and then at the end of the software. So the less you are involved in the art, the less you are involved in the final result, the more you become support, the more you're probably scripter and so on. And so generally, as I always say, the Python beginner is like artist to technical artist, and then slowly bleeds into advanced Python, because then you start to work in a team with others and so on. And generally, I say it's actually not as long to learn the basics of that. So for example, technical artists, I would say you can learn it in 8 weeks. Read and write Python code and write simple, helpful applications. So if we look, for example, at my students' work in Maya, after 8 weeks, we see this. We see auto riggers, we see distribution things, we see auto like rig mapping, we see shading, texture tools, and so on. So that's after 8 weeks from 0 to this. And this in you. And on the other side, if you want to become more of a technical director, maybe going even into pipeline TD, it takes maybe 6 to 12 months, obviously depending on the situation, because then you want maybe to create pipeline relative applications that can be interlocked into the project. And it's a code with other people in the team. And finally, software developer, obviously that's much higher. You need to have probably maybe even a little bit of C++ and so on. That can take a few years. And then you want to create advanced application and maybe work, yet you are 100% full-time programmer, basically. And the most common things why people fail to learn generally Python or maybe advanced is because of mentality, like I cannot do it mentally. You learn alone, which is always a bad idea. You have no clear deadlines. You just kind of like learn slowly. You have no clear structure, no feedback while you do it. Feedback is so essential. You have no way to ask questions because, you know, you work with your YouTube videos and so on and so on. So that's why I'm not the biggest fan of Udemy, Skillshare, and Code Academy, because that's what happens if you just watch videos. Yeah, I'm a big believer into cohorts. I'm a big believer into environments where you learn, you watch some videos, but you do assignments, you talk with other people, you ask questions, you get feedback on your code, because that's where you really, really learn, and that's you not only motivates you, but also brings you forward at the end of the day. So the best way to learn Python is to script helpful tools. And then just to wrap this up, let's look at some students' work after like 8 weeks of training. So this is the things that you can do. Here's from Snappy tool for rigging. You can snap it for a situation. This is basically after 8 weeks you created. Can't you create this tool here to connect things, and you can see here that you can import nodes, you can set up match, and so on and so forth. Then we had this tool. It's really cool. It's about it's in Max now to distribute for layout. For example, you can distribute the stones by changing the values, and kind of connected to that we did in the forest. Here, the same tool that I just mentioned before, but for loading and opening files, basically. The loader here for close tool in Houdini, simply, especially for games, and then shading, so restructuring what shading information you have, how do you access, maybe some helpful tools, and so on and so forth, basically. And if you're interested in learning more, besides the masterclass and course that I have, you're welcome to watch my blog and my YouTube videos. We always talk about TDs, technology, scripting. We have every 3 months, we have cohorts and so on. And that's my focus, basically. I'm a big believer into bringing everyone a little bit to a technical direction, because I believe we are in a technical environment. And even if you're an artist, and you should stay an artist, that's totally cool. I think your life will be better if you know basic logical, technical problem solving, basic technical scripting like Python, because then you can, improve the output of your work, and you can focus more on making great art, and you write a few scripts to, distribute and like automate the boring stuff, basically. And I think that is why I'm so focused on that, and that's why I'm a big believer into, everyone should become a little bit of a technical artist, a technical director. And that's basically it from me. I hope I could catch everyone, even from non kind of Python user to a little bit Python user to maybe even advanced Python user, and get a little bit of this environment going of like where I see Python and visual effects, animation, and also games. So thank you very much. We can go over to the Q&A if someone has some questions to any of that.
Yeah, please. First, thank you, Alex, very much for this great presentation on Python. Before I can wait a little bit if somebody has questions, but I have some questions myself, or maybe more some orientation of explanation. You, in one of your presentation, you said the Python is a glue between different software packages, and so how do this colorate now with USD coming in the game?
I mean, it's even better. Before that, what happened was you would write an exporter, for example, a publisher, and you would need a more, like, oh, this exports in ABC, this exports in FBX, this exports in OBJ, and so you had a little bit more of the kind of like separation, and you basically had to code more. Because then you have to export depending on the environment, maybe sometimes, because maybe it's optimized better. But with USD, you can basically create one exporter for USD and then throw it at something. And as long as USD exists in the software, they can basically, like with the loader, just like use more or less the same code. Obviously, the line will be different. It will be a Maya export line and an Houdini export line. But it doesn't really change much in terms of Python in itself, but it changes a lot in terms of pipeline, basically. So the workflow and the structure and the flexibility. And also it introduces, as we did like a TD meetup on USD with Carol, and it creates also this endless pit of, you can make USD very horribly wrong, and then you have more problems than anything else, because USD too many options. So you can make your things so complicated. But in terms of coding, it actually, I think USD introduces more coding because it's at the moment it's very badly implemented. At the same time, it has a lot of potential. So if you know coding like Python, you can basically open USD much bigger than anyone who can just use the Maya plugin for USD or whatever. So I think that is there. But in terms of in itself for Python, it doesn't make any difference, more or less.
You showed one of your examples with Max, with this aligning the stones and something like this. Yes. And when I saw that, I just remembered that Max has this also a node-based thing that is really much more complicated than Houdini node system to do that. Geometry nodes in Blender, it's, I think, very similar thing, or doing it like this Python, but it's with nodes. It's something. How do you think can you as or a Python, somebody that wants to learn Python, can boost up the geometry nodes, or is this something that you have to look them separately? So have you worked with geometry nodes in Blender? Have you had the chance to see that? It's something like Houdini procedural geometry creation and automatization, but it's something like, it's not exactly, but it's going in that direction.
I never used Blender, so I cannot say much to that. But I think the question is very similar to what I got as in Houdini. So when I did Python for Houdini, the most common question from professional Houdini user were like, why should I learn Python? Because I can make a Houdini network. Like I don't I can literally procedural generate things with the Houdini network. Like, why should I Python? And then there's VEX on the other end of and it became like a little bit of this thing where at the end of the day, you need Python much more in Maya and 3ds Max and in Nuke, where Houdini is pushing itself a little bit out, but you still need it. So the interesting part is basic to what I said before. Node networks is visual scripting. So if you can do it visually, like node networks, you don't need the scripting, because it is scripting under the hood. Like, if you write it in code or connect some nodes and you have the same result, do whatever works for you best, basically. Mm-hmm. But when it comes to automation and pipeline, Houdini has no options. If you want to export stuff in a certain way, in a certain kind of like naming convention and so on, there is limitations to what a Houdini's nodes actually could do. So when it comes to connecting other departments to your department, to other software and so on, there is no way around Python. Even VEX has no options. No other languages in Houdini has the option of exporting correctly in that complexity, importing, managing things as much, creating node trees, basically to some degree. So that is like the purpose of Python can change a little bit depending on the software, because the software maybe has alternatives like visual coding, for example, node coding. That is the biggest thing. But at the end of the day, everyone, even Houdini users, even FX users, would benefit from Python because it can help them with all this exporting, importing, naming convention stuff, where there is a limit how much you can do actually with node trees at the end of the day. Yeah, exactly. So the production will benefit. The VFX Artist depends a little bit, because, for example, VEX is a little bit faster than Python because it's more embedded into that. But in theory, like, also the benefit a little bit, if you know Python, you can do everything. But if you know VEX, you can only do this thing. So the benefit is maybe Python is not as fast as VEX, but you can come from somewhere else and still use the same thing. And the same thing if you go into 3ds Max. Max script is better than Python because Python is horribly implemented into 3ds Max, but it basically can do 99%. Even if the Max script is a little bit faster than Python and 3ds Max, you can come as a Python user and work in Max without not learning a new language, basically. So Python has this, sometimes maybe not the optimal way, but it is this. I have a hammer and I can work with this hammer everywhere. And I can get the job done everywhere. So if you're not an expert in Houdini node trees, I probably will create a Python script instead of node trees, because I'm more familiar with Python scripts. Yeah, exactly. But you will probably create maybe node trees because you're more familiar with that. But because I know Python, I can literally jump into every software and ignore the native environment and just like do my own thing using Python as the main language because everyone speaks it basically. So that is an amazing benefit where you don't need to spend like 3 years to learn a software just to speak the native software language basically.
Great. We have one question, I think two. First comes from Matthias Voigt from Platish. Given Python's popularity and flexibility in the visual effects industry, what are the main challenges or limitations you've encountered while using Python in production? Is there anything about the language that you dislike or find frustrating, especially when working on large-scale visual effects projects?
The only thing, if you work in a real programming language, so very important, programming and scripting language. Programming language is compiled. You create the code, you compile it, which means there will be binary code at the end, so you cannot read the final code. So it takes a moment to compile. So that's a C++ and C# you need to compile. Scripting languages you see, and that's what the computer also sees more or less. So basically, it's faster at the end of the day in terms of executing, but it's slower in terms of results. So compiling language like C++ will always be faster than Python at the end of the day. One of the things that's frustrating as a more advanced coder with Python is it is a little bit forgiving. And that it's cool in the beginning, but it gets a little bit annoying at the end when you're not sure what kind of what's the variable input, because it can change all the time. So sometimes Python is could be a little bit more, strict. And so it sometimes feels like, this language doesn't want to be on the highest level. So that can be very strict. And I think in professional productions, a big problem is a lot of people are not native Python users. And that's a really big problem, because you can see they use their C++ background or their ML background and they push it onto Python. And then it sounds like my grammar is off. Like I would use German grammar on English sentences. And it's like, that's kind of weird. And sometimes it's really hard to understand if someone is not native Python user. And this can be very frustrating, to read and understand. And combined with this high level clarity that can sometimes lead to a little bit of complexity, I would say, with Python in general. But in terms of anything else, Python is definitely the easiest language to read and to write, comparably to any C++ or whatever. It's much, much more complex. You can do much more stuff in less code than when in C++ you probably need 3 times, 5 times more code for the same action, basically, in the end of the day. I don't remember the first question part, basically. What was that one?
What are the main challenges or limitations you've encountered while Python using in production?
To be honest, you can do everything. I don't really encounter time. It's probably the only thing that you how much time people give you to solve certain elements, and then you end up with a half-baked solution that will not survive the next project. Basically, I think that is the biggest problem in Python. But at the end of the day, documentations, it's very vastly different. 3ds Max is one of the worst documentations in existence. It's horrible. It doesn't exist, basically. So it's nightmare, basically. So that can be it can depend on the environment. Houdini has a few bugs. In Python, Max crashes on certain situations. So that is probably there. But in terms of production, I think the biggest problem is just time. That people don't recognize the benefit of an optimization in Python. And sometimes they think, oh, you do it in a day and that's good. While if you would spend a week, you would really benefit in the midterm, in the next few months, maybe even the next project, and not just in the next 2 weeks, and then you have to fix it because it's not good. Well, so time is the biggest problem. If you spend more time and money on pipeline, then you would benefit so vastly at the end of it.
Thank you very much for this talk. We have to move on. We can talk for this hours, I know, because Python is really a vast team for everything. And thank you for being here, Alex. And check the website from Alex. He has also he's offering some courses as well. Check maybe something that you will find there that can help you in this direction.